Welcome to Engineering Mechanics video lecture. In this video lecture, I am trying to explain you about work energy theorem in curvilinear motion of the particle. Consider a particle is moving in curvilinear motion from here to in this direction. On this travel, we have to consider a point which is there on the trajectory P. At this point, we have to consider normal acceleration and tangential acceleration. Opposite to the normal acceleration and tangential acceleration, we can consider inertia force along normal direction and tangential direction. When the particle is moving in curvilinear motion up to reach P point, which is there on the trajectory, the tangential acceleration is considered as at, normal acceleration considered as an. Opposite to tangential acceleration, the inertia force generated within the moving particle is considered as Ft equal to mat. At the same point, normal acceleration taking place towards the center of curvature. Opposite to normal acceleration, centrifugal force will be generated that will be exactly equal to Fn equal to man. At the same point P, which is there on the trajectory, weight of the particle which is acting downward direction, that is indicated as mg, weight equal to mg, that is theta inclined with normal reaction force. For that mg force, when it is making theta inclined with normal reaction force, adjacent component founded, that is mg cos theta. Opposite component to theta also founded, that is mg sin theta. Mg sin theta is directing opposite to the tangential acceleration. Mg cos theta is directing along the normal acceleration direction. While writing the equation of dynamic equilibrium along normal acceleration direction, normal reaction considered as minus, mg cos theta considered as positive, centrifugal force Fn equal to man considered as negative. Why? Because the direction of centrifugal force Fn equal to man and normal reaction force direction are opposite to normal acceleration, and mg cos theta is directing along normal acceleration direction. So we can consider mg cos theta as positive. While we are writing the equation of dynamic equilibrium along tangential direction, tangential component of weight force mg considered as negative, Ft equal to mat also considered as negative. Why? Because these two forces are directing opposite to the tangential acceleration. When you write the equations of dynamic equilibriums along normal direction and tangential direction, we can get summation of the forces along tangential direction exactly equal to mat, and summation of forces along normal direction equals man. The forces which were perpendicular to tangential direction, which are acting on the particle at P point, are not giving us any work done. Only the forces which are acting along the tangential direction need to give work done. Using dynamic equilibrium equation, Along tangential direction, we try to find the work energy theorem. We can write mass of the moving particle in terms of weight as W by G. Write tangential acceleration AT as dV by dt. Using chain rule of differentiation, we can write dV by dt as dV by ds into ds by dt. Then we can write W by G into dV by ds into ds by dt equal to summation Ft. From this equation, ds by dt indicates us instantaneous velocity of moving particle. We can indicate that as v. In this left part of the equation, dt is dividing dv. When you take dt to the right part of the equation, dt multiplies summation ft. In this left part of the equation, ds is dividing dv. When you take ds to the right part of the equation, it multiplies summation ft. W by G into V into dV equal to summation Ft into ds. Integrate this equation both sides within the limits of velocity and displacement. Integration u to v W by G into V dV equal to integration S1 to S2 summation Ft into ds. In this given equation, W by G is constant, take out from the integral. Summation Ft also constant, take out from the integral. In the left part of the equation, integration taking place about velocity. In the right part of the equation, integration taking place about displacement. Integration V dV indicates as V square by 2. Integration ds indicates as S. W by G into V square by 2. Integration limits varying from u to v equal to summation ft into s. Integration limits varying from s1 to s2. When you apply these integration limits, we can get W by G into V square minus U square by 2 equal to summation Ft into S2 minus S1. Finally, we can write it as of W by G V square minus of W by G U square equal to summation Ft into S2 minus S1. This indicates us the change in kinetic energy of the particle between 2 points or 2 positions on its path is equals to the work of all the forces acting upon it during the motion between these 2 points. On the trajectory, we have founded the work and energy equation when it is moving from here to in this direction. On this trajectory, we have to consider this point as uh, 1. Up to 1, the displacement covered is S1. And also another point we have to consider 2. Up to here, the displacement covered is S2. In between these 2 points, we are going to find the work and energy theorem. We have founded it as final kinetic energy minus initial kinetic energy exactly equal to work done.